SimpleFOC is an open source library for controlling brushless DC motors and stepper motors. It supports a wide variety of hardware such as large hoverboard motors, small gimbal motors and stepper motors, and can run on different boards such as ESP32 boards or STM32 boards or Arduino based boards, and can get sensor data from a variety of different types of sensors. So regardless of your setup, this tuning guide aims to provide a strategy from getting you through from project setup to open loop control modes through to closed loop control modes. In the first part of this guide, this video, I'll be going through open loop and getting some sensor information back, and in the second video I'll be looking at closed loop mode. So to provide a bit of context, I'll be using a hoverboard motor and I'll be powering it with a STM32 discovery kit for drones, and the sensor information will be from Hall sensors that are on the board. Step 1 is creating the project and choosing the board. I'm using Platformio here. You can skip this step if you're using Arduino IDE. I've done a longer intro guide to SimpleFOC and Platformio, which might be over here or something. I'll kind of rush through this. So I'm clicking open, new project. I'll give it a name. And choose my board. I'm using the drone development kit from STM again. Click finish. So that will also go and grab the build tools required to program STM boards for you. So the platformio ini file, that one basically is the project settings. So I like to sort of paste in a few kind of normal standard settings that I tend to use. They are actually, some of them are somewhat dependent on the board. So it's already got the platform STM32 and the board and framework that we chose during project setup. I'll set the baud rate to this sort of standard speed, and this is basically telling the project how we're doing serial. So it's going over USB here. And then I can specify the dependencies. There's a couple of ways of doing the dependencies. I tend to use the sort of direct git URL here. I just swapped from main to dev to main branch there. So that's that. I haven't got any code yet, but I can Control-U to upload it. So we basically have programmed the board, and that's the end of step 1. So step 2, super quick step, setting up the serial, basically for read and write. So what we're trying to do here is, rather than upload the sketch each time, then we'll just have like a generic target variable that might represent angle or velocity, that sort of thing, and we can change it using the sort of serial.read function here. So give you a quick example. I'll upload that, and if I type 2.0, again I've changed a tuning parameter without having to reprogram. So we'll be using that target quite a bit in subsequent steps. So for step 3, I'm going to look at getting sensor feedback information, so angle and velocity readings. I could have done open loop motor as step 3, but I sort of arbitrarily chose to go after the sensor info. So in my setup here, which is a hoverboard motor, I've got Hall sensors on that. So for this step, I'll be sort of setting up a Hall sensor. So I'm going to, in Arduino, I'm going to hit Control P, which brings up lists of files. It also brings up files in development projects, libraries. So SimpleFOC is a library here, so I can search for examples and Hall. and hopefully yes, it's found one of the examples. So I'm going to start stealing code. I'll steal all of this. You can see I've got the SimpleFOC include, and I'll need to change obviously the pins that the halls are connected to. My board defines these pins as as defines. I'll show you. And we've got a 15 pole pair motor here. So the hall 1 is port B6, port B7, port B8. Then we've got the interrupt handler functions, and we'll need to copy some more code for the setup. So don't think I need that pull up extern because I think that's the default anyway. So I'll grab these. There we go, and I'll steal the printouts in the loop. And upload that. So it should start printing out the angles now. So the left column, as you can see, is the angle, the right column is the velocity. If I lift this up here, I will try and spin it through 360 now, so that'll be 6.1 radian. I think that was it. Yeah, and put it back. Yeah, so that seems to be working okay. And you can see the velocity there, velocity reading on the right. So step 4, we're going to make the motor move. So we're going to go for open loop velocity mode here. And again, I will copy code. So examples, open loop velocity. There we go. And I will start copying code. So basically we're copying the initialization for the motor and the driver here. So that motor is a 15 pole pair motor, and I'm not using a 3 PWM driver. I'm on my drone controller, it's got 6 PWM. Basically each of the 3 phases has got a high and a low gate, if you know what I mean. So I need to put in the phase UH, the 6 PWM pins here. Phase UL, phase VH, phase VL. You might need to do some, investigation as to what pins to use here. So you can see this one's port A8 and that one's port C13, etc. Back to stealing code. So I will grab all the way from voltage power supply to the init here and paste that in. So let's look what we've added. So we've said 12 volts voltage power supply. We init the driver, we link the driver to the motor, set a voltage limit. I'm going to drop this to 1 because the resistance in my hoverboard motor is pretty low, and I don't really want to burn it out at low speed, and that could happen in open loop. It's less likely to happen in closed loop. Happy with the velocity limit, and yes, we've got velocity open loop as the control type here. Okay, so that's stolen. I will just, there's a last bit to steal, which is we need to tell it to move inside the loop. It doesn't have, you don't have to set this all the time actually, but I will anyway because I'm and this set the target. Remember my general use target variable, and I'll set this target to start off with 1. So essentially here we're able to change the the velocity by later by entering things in the serial port. So I'll upload that, and I'll turn my power supply on. Power supply is limited to 0.6 amps, just to stop anything getting too hot. And as you can see, the motor is starting to turn at 1 radian per second. I will change that to 2, and that's moved. So one thing, the amps on my power supply is down at 150 milliamps, which kind of tells me that it's about to stall. And I'll keep on going, and you'll start to see it misbehave. So at 4, I'm asking for 4, and it's misbehaving. I can give it more open loop sort of voltage. So I'm going to change my voltage limit to 2 now. That's quite a bit more juice. So it's going to be burning a lot more current all the time now because it's open loop. There we go. So I should be able to go a little bit. So you can't see it, but my power supply is actually dropped from 12 volts to 8 volts because the current is being held at 0.6 amps. So it's on the verge of a brownout on my microcontroller. So I'll go to 2-speed. Oops, I don't know what that was. I think I typed the wrong character. So that's 3 radians per second. I'm still at browning out. I'll go to 4, 5, and 7. So back to 5. So you can see I probably need to give a little bit more current than 0.6 amps really. So I'm running at about 6 radians per second here, and I can go backwards too. -2, -4. There we go. I mean, reality, these hoverboard motors, I'd probably give it 24 volts and a couple of amps limit, so that's why it's sort of struggling. So we've got data from the Hall sensors, and we've seen the motor move in open loop mode. So the next video will be doing closed loop mode, where we combine the sensor data and start using the FOC algorithm.